Okay, hi guys. Okay, so finally the stream has started. Yeah, I was waiting for a long time for the stream to start. So first of all, hi everyone, how you guys doing? So let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. On this channel of YouTube, every concept of physics, chemistry, and maths are being taught to you completely in English. So this is a series that I host for class 12 students who are looking to give their JEE in 2021. So this is a quick review series where we quickly go over the key concepts and we discuss some previous year problems. So today we are starting a new topic for the quick review, and this topic is thermodynamics. Okay, so let's start with the part one of today's review. Now, before we get started with today's class, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi, and for almost past 8 years I've been teaching physics for the JEE exams. Now, all this my experience of mine had been offline, and this is the first online venture that I am exploring. All right, so I myself as a student was All India rank 447 and All India rank 1 and 2 in the two stages of the IIT JEE exams that I took. I also qualified the NTSC Stage 2 examination, and I was in the top 1% in the NSCP exam as well. Now, I've already coached many students to top ranks in the JEE, both mains and advanced, in the offline setups, and now I hope to continue doing that here online with you guys. Okay. So, as I said, before this year, all my teaching had been offline. So, I'm myself very new to this online setup. So, this lockdown period has forced all of us to adapt. So that is why I am here, and that is what you guys can do as students. Okay. So I'm sure this lockdown has brought a lot of problems to a lot of students who are serious about their examinations and they don't know how to prepare well and where to go. So you can get yourself the Unacademy subscription. So this subscription will make sure that your studies are going on uninterrupted and smoothly even in this lockdown period. So when you get the subscription, you will get benefits like live classes, where you get to interact with your educators, and where you have live polls and leaderboards which keep them highly interactive and efficient and fun. You also have regular test series and analysis sessions which keep you on your toes, which keep you aware of the competition and you're standing in it. And of course, you have live doubt clearing sessions. So that's another great feature that you get with your Unacademy subscription. So this subscription will uh, give you access to all the Unacademy Plus courses, and all the Unacademy Plus courses have this feature of conducting live doubt clearing sessions after every three teaching sessions. So every fourth class of any live Plus course is supposed to be a live doubt clearing session where the student can ask all their doubts. Hello Shivam, good to see you here again. Okay, so you can ask away all your doubts, be it related to problems, be it related to theory. So that's a wonderful feature. That is one opportunity that you usually do not get online, or even in offline. It used to be difficult for students to ask for their doubts. So here you have regular doubt clearing sessions, so they will make sure that your doubts are not piling up. Now, apart from all these benefits, Unacademy is also giving you a chance to study from all the top educators all across the India from the comfort and safety of your home. Now, earlier all the students had to move to big cities like Kota and Delhi, which were the coaching hubs, right? And now with the Unacademy subscription from your home, you can study from all those top teachers. Okay, so that's a huge opportunity. I think which is worth materializing. Now, the first step towards achieving all these benefits is to install the Unacademy app. Now, the moment you do that, you unlock yourself a lot of free features. So these free features include some free courses that are available on the Unacademy Plus. Plus, you have special classes. We just had a special class. Okay, so that is another great feature. Okay, which you can attend absolutely for free without even buying the subscription. And of course, you have free quizzes like the ones that we keep posting every Tuesday. So you unlock yourself all these features just by installing the app. Okay. So without even having to pay for a subscription, you can experience what it's going to be like on Plus. Okay. Feel all the free features. And then if you like those free features, and if you decide finally to, yes, I want to enroll in the courses, okay, then you can decide to get the Plus subscription. Now, this is how you get yourself the subscription. You need to go to the Plus section of your app, select your goal as IIT JEE, and click on that Get Subscription button. Okay. Now, when you do that, you will be redirected to the payment page where you can use the code RD Live. So you will have a box which will say, "Do you have a code?" That is where you can use this code RD Live. And the moment you click on apply, you get an instant 10% off on all your subscription fees. You realize that all the subscription fees are in any case kept very modest. Okay, so if you talk about a 24-month subscription, it comes to about 2,100 rupees a month, and a 12-month subscription is coming out to be 2,800 rupees a month, which is way less than what people are paying for their home tuitions. Okay, so from what I heard, some people that I know of in class fifth and sixth, the students were paying 4 to 5,000 rupees for their tuitions. Okay, so you are getting a great quality content from the topmost educators at such a competitive pricing, which again will be made even more attractive if you use that code RD Live. Okay. Now you can choose from two kinds of subscriptions, Plus or Iconic. The fees of both the subscriptions are as listed below. Okay, and now you will realize when you click on that proceed to pay button, you also have a lot of no cost EMI options to make these payments. Okay, so yes, Shivam, let me get to that. Just give me a couple of more minutes and then I'll take up you down. Right. So as I was saying, even this fees you don't have to pay in one go. Okay. Now you realize any reputed offline coaching setup would have charged you anywhere between 4 times. That's the minimum that any reputed institute is charging these days. To even 10 times this fees. Okay. Some top institutes even charge around 10 times this fees. So you are getting to study from the topmost educators all across India at a very reasonable price. So I think it's an opportunity that you must encash. It's a subscription that is a must have. Now let's tell you about the iconic subscription a bit. Okay, because most students don't know about this. So the iconic subscription is another feature that Unacademy has introduced recently. Now this subscription will take your JEE preparation to the next level with personal coaches. You'll be assigned a team of personal coaches from our team of experts. You will be attending regular IIT JEE workshops. You will be receiving time-to-time expert guidelines. You will be getting a study planner of your own, and you will have test analysis sessions. So all these features, along with a personal coaching and guidance, will make sure that your JEE preparation goes very smoothly, and you propel to those top ranks that you have been hoping for. All right, so now the top educators from Bunsen classes are also teaching online on Unacademy. So as I told you, now with the Unacademy subscription, you have a chance to study from all the topmost educators from all across India. So you can enroll in these courses also. Okay, the batch is starting from 21st of December. All right. For those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link so that you're receiving all timely notifications of all the sessions and lectures happening here on YouTube. So, hello Rajesh, hi AP, how are you guys? All right, so now it is time to start with our quick review session. Now, before I do that, let's take a look at Shivam's doubt. So, what is Shivam asking? So, Shivam is asking a block of mass M is attached to a pulley disk of mass M and radius r by means of a slack string as shown. Okay, the center of the pulley is hinged about its center. On a horizontal table, the block is projected with an initial velocity of 5 meter per second. The velocity when the string becomes taut is okay. I gave you a rotation test today, but I only got 1 out of 40. Ah, hmm. So I think you need to watch the lectures and practice some more. Okay, Shivam. If you had watched all the lectures closely, I have discussed most of the concepts that would have been needed to solve those problems, right? So just go through the lectures, make your own notes, make sure you are understanding all the concepts, and then make sure that you're solving various problems. Okay. So not only your HCV, you are solving all the sheets that were given to you, and make sure you're getting your doubts cleared. Okay. All right. So let's talk about the question that Shivam has. So the question is something like this: you have a pulley which is hinged at the center, and with the help of a slack string. Okay, so there is a slack string, and there is a mass which is given an initial velocity of 5 meter per second. Okay, so what will happen? What will happen? Okay, so what is the mass of the block? You'll need to give the details of the mass of the block. Okay, mass of the block is m and equal to the mass of the disk and radius r. Okay, so assuming this has a mass m, this also has a mass m, and this has a radius of small r. So what will happen is, all right, no problem, no problem. So imagine the moment the string becomes taut, what will happen? That there will be a jerk. Okay, a jerk will be received by this. Why? Because initially the pulley is not rotating. Now, the moment the string becomes taut, you know the property of a taut string is that both the points at the ends of the string have to move with the same velocity. So, if this starts to move with a velocity v, this point also should be moving with a velocity v. Now, to provide that velocity v, the tension would have provided a jerk to this pulley, which would have started rotating it. Yes, an impulse would have been provided, and the impulse would have been provided to this guy also, this mass also, which would have slowed it down, right? Now you realize the moment this string provides a jerk here to the pulley would have tried to move forward. So to stop the pulley from moving forward, another jerk would be provided from the hinge. Okay, so hinge will provide another jerk which will stop the pulley from moving forward, and it will make sure that pulley only rotates and does not move forward. If the pulley was not hinged, you would have realized the pulley would have gotten dragged along with the mass, right? So now, if I consider both of these as one system, if I consider both the pulley, the string, and the mass as one system, then the only external impulse that my system is receiving is from the hinge. Correct? Agreed? Yes. Yes. So there is one external impulse which is being provided by the hinge, right? So if I also know that this impulse is passing through the center of the pulley C. Okay, so let's give this a name C. So do you realize about point C, there is no external angular impulse. Okay, so since this impulse is passing through the center of the pulley C, so with respect to point C, there is no external angular impulse, right? This cannot produce any torque. So I can say with respect to C, with respect to C, there is no there is no external angular impulse on the system. Now I know if about a point there is no angular impulse, so what I can conclude therefore the angular momentum of system about C will remain conserved. Agreed. So I will apply conservation of angular momentum with respect to point C. Got it? So what was the initial angular momentum of the system? Initial angular momentum was it was moving with 5 and this distance was r. So initial momentum angular momentum was mvr, m into 5 into r. This was the initial angular momentum. Finally, it is moving with v. So finally, the momentum of angular momentum of this particle would be m into v into r, plus you will have an angular momentum due to rotation of the disk, right? So due to rotation of the disk, the angular momentum would be half m what yeah, okay, so this is hanging. So just give me a sec. Hmm. Yes, here we are. So the angular momentum due to rotation. Hi Motilal, how are you? Angular momentum due to rotation would be half mr square, which is the moment of inertia into omega. Right. So from here, mr and mr would have gotten cancelled, and you will know that from here the velocity of this point is also equal to omega r. So omega r would be equal to v. Okay. Yes, that happens sometimes. So also omega r is equal to v. So the point of the string has to move with the same velocity. So what I am getting is that 5 equals v plus v by 2. So v equals 10 by 3 meter per second. Okay. So that is your answer. इसका mr² by 2 होता है एब्सोल्युटली, और ओमेगा आर भी आपका v के बराबर हो जाएगा। सो ये आपका आंसर आ गया। अभी समझ में आया कैसे सॉल्व करेंगे? आई होप दिस इज क्लियर, राइट? गॉट इट? This is how you would have solved this. Applied angular momentum conservation about point C. Okay. So if that is clear, should we move on? Can we move on to today's discussion then? All right. Hmm. All right. So again, let's get started with quick review part one of thermodynamics. So first we'll talk about heat. So how do you define heat? Now, heat is defined as a form of energy in transit between two bodies by the virtue of difference in their temperatures. So whenever you take two objects which are at different temperatures. Now, due to this difference in temperature, they will exchange some energy. So, if the temperatures are T1 and T2, now due to this difference in temperature, they will exchange some energy. So, from heat is the energy that flows from a body of higher temperature to the body of lower temperature, and this form in which the energy is flowing, this form of energy is what we call heat. So heat is a form of energy. It is that form of energy which will get transferred from one body to another by the virtue of difference in temperature. Okay. Now, in the old days, also people realized that heat always flows from a hotter body to a colder body. So, what their idea was initially that heat was thought to be an invisible fluid filling all objects, which they used to call caloric fluid. Okay. So, what they thought was just like if you so the idea was they related this to fluids. So imagine a container which has, let's say, water up to a height like this. Okay, and you have another container which has less amount of water. Okay, so imagine another container which has less amount of water. Now, if you connected both these, then what would have happened? If you connected both these, then what would have happened? That water would have flown from higher level to lower level. Correct? From higher level to lower level, the water would have flown till the level of water in both would have become equal. Now that is what they realized. That is what they realized. Okay, that is something similar that is happening between hot and cold bodies. They realized if I take one body at temperature T1 and another body at some temperature T2. So imagine if T1 is greater than T2, then they realize that energy gets transferred, heat energy gets transferred from here to here till the time both their temperatures become equal or both appear equally hot or equally cold. So they thought, drawing this analogy, they thought that heat is an invisible fluid which is filling up all the objects, and whenever I keep two bodies together or near each other, the liquid flows from its higher level to lower level until both of the bodies have the equal level of heat. So you realize if you keep a hotter body with a colder body, they will exchange heat, and then after some time, when you touch them, both of them appear equally hot or cold. So that was the idea, and this invisible fluid was initially called caloric fluid, and that is why the energy of or the unit of energy of heat energy was chosen to be calories. Okay, it was only later that Joule established the fact that is nothing but a form of energy only. So before that, people did not realize heat was energy. They thought it was some kind of invisible fluid which was flowing from one body to another. Okay, that is why they used to measure it in calories. And now also you might have wondered, I already have a unit for heat energy, right? That is joules. So why don't we always measure heat in joules? Why in calories? It is for traditional purposes. Okay, traditionally it was measured in calories because it was thought to be some related to an individual fluid, which they then called caloric fluid. Okay, now in the modern view, we know that it is just a form of energy, and due to the old definition, we still use the unit calories, and now we know the conversion factor between calorie and joule, which is this. Okay, all right. Now, the first thing that we will talk about when we are reviewing thermodynamics is the zeroth law or thermal equilibrium. Okay, so two bodies are said to be in thermal equilibrium if there is no net heat exchange happening between them over a period of time. So that is the definition of thermal equilibrium. So two bodies are said to be in thermal equilibrium if, please note, no net exchange of heat is happening. So we don't say that they're not exchanging heat, but there should be no net exchange of heat, which means imagine two bodies which are kept near each other. Imagine they are exchanging heat. They will always be exchanging heat. We will study about that later. But if it happens like this, the amount of heat that body A is giving to B, if that is equal to the amount of heat that body B is giving back to A, if both these heats are equal, then there is no net heat exchange happening, and then the two bodies are said to be in thermal equilibrium. Okay, that is what is thermal equilibrium, when no net heat exchange happens. Now, okay, so heat was proved energy by physics or by chemical process means what is the origin of its proof as form of energy. So it was proved by Joule in his experiment. So there is a experiment done by Joule where he proved that heat is a form of energy. It is equal to mechanical energy. In fact, it can be generated from mechanical things. Okay. So the proof was in physics. Joule had proven. So I don't know if you've heard about this Joule's experiment. Joule's experiment says that what he did was he kept a fluid. He kept a fluid and he kept a blade here. Okay, so Joule had this kind of an arrangement. Okay, so what he realized was that if there was this kind of blades, okay, and what he did was he connected this blade to a string that was passing over pulleys, and here was a mass which was going down. And as the mass was going down, this pulley or the fan rotated, right? It started rotating. Now, when it started rotating due to viscosity, it generated heat. It generated heat, and the temperature went up. Now, we initially people thought that temperature can only change when you give heat, right? And if the temperature is going up, you are not giving heat from anywhere else. It is getting transferred from a mechanical process, and you realize this was also accelerating at a rate less than g. So the energy, the potential energy of the block was getting converted into heat energy, and that is why the temperature was rising. So that was how Joule established that mechanical energy can be converted into heat. Mechanical energy can increase temperatures. So energy has to be a form of heat. Okay, that was Joule's experiment, and that was his idea. Okay, Shivam. So it was the great Mr. Joule who talked about Joule's equivalent. He also told you that 1 calorie was equal to 4.2 joules. So this was also given by Joule in his experiment only. Okay. So again. So that was Joule's experiment. Now we will talk about zeroth law of thermodynamics. Now, what is zeroth law of thermodynamics? The zeroth law of thermodynamics states that if two thermodynamic systems are in thermal equilibrium with a third one, then they are also in thermal equilibrium with each other. Okay. So again, it might again be obvious to a lot, and I will prove that this is not something obvious. So it is something which is hiding a very depth, a deep meaning. Okay, and that is why this was made a law. Okay, because what this law is saying is that imagine if body A is in thermal equilibrium with body B. Okay, imagine these two bodies, and imagine that they are in thermal equilibrium with each other. And it says if body B is in thermal equilibrium with C. Okay. Then what this law implies is that then A and C will also be in thermal equilibrium. Okay, so if you notice that body A is in thermal equilibrium with B and B is in thermal equilibrium with C, then C and A will also be in equilibrium. Now, is it not obvious? So why is there a need to call this a law? Why did we have to call this a law? In fact, what you will notice is that this is the zeroth law. Now, when you talk about laws, you have first law, second law. This is the first time you will see zeroth law. You know why this law is the zeroth law? Because the first law, second law were introduced before this. The first law of thermodynamics and the second law of thermodynamics were actually declared before this. And then they thought, okay, there is a much more fundamental law that we need to add, and that law should come before the first law and the second law. That is why a zeroth law was added in thermodynamics. So not only is this not very obvious, it has a very deep under meaning. And that is why this law was added later as a zeroth law. Okay, hi ARJ, how are you? So first of all, how many of you think that this is very obvious? There was no need to even establish a law. Why is the thumbnail three glucose bottles? I have no idea. Sir, Earth's core is hot when they do. Then why do glaciers form on Earth? Why not? Why? Why they do not melt due to equilibrium? Okay, does they melt by sun's heat or equilibrium by Earth's core? Okay. So first of all, first of all, okay. So that kind of explanation to explain that, I will have to take a long detour from my discussion for today. Okay, so we'll maybe discuss that somewhere sometime or the other. Okay, some other time we'll discuss that. Okay, that why are glaciers melting? Glaciers are melting because of the heat which is entering the environment because of the lower ozone layer, depletion in ozone layer. So earlier a lot of rays of sun were blocked by the ozone layer, so they would not reach the surface. But now, due to depletion of ozone layer, some really powerful rays, ultraviolet rays, can reach the surface of the earth, and those are causing a rise in temperature of earth. Okay, so again, earth, you realize earth is in thermal equilibrium. Earth's average temperature should have remained constant, right? Why? Think about this. When earth is rotating, the first half is receiving sunlight and heat. Okay, but during the night, the second half is actually radiating away heat. This is radiating away heat, right? So that is why during the day temperature rises, during the night the temperature falls. So Earth receives heat energy from sun in the day, and when it rotates, it eventually starts radiating that away also. Okay, so Earth overall should have remained in equilibrium. Okay, if it radiates the heat at the same rate at which it absorbs the heat, external heat. Yes, absolutely. ARJ is absolutely right. ARJ is absolutely right. When we talk about conduction, I'll tell you that. I will tell you that. I will tell you that. In conduction, you will realize even though the Earth's core is really hot, but there is such a thick layer between the surface and the core that the conduction, due to this conduction, the amount of heat that you receive to the surface is almost negligible. And because you keep receiving energy from the sun, so again, there are other factors also. So a lot, very complicated thing. However, let's get back to the discussion at hand. Isn't this obvious? Isn't this obvious? Is this not obvious? First of all, try and answer that. Try and answer that. What is the significance of the zeroth law? What do you think is the significance of the zeroth law? Why did they have to go back, add another law with the name zeroth law? Why would somebody take so many efforts with something which seemingly is very obvious? Okay, so think about this and try and answer this. Okay, so tell me, can we wear Earth's crust on hot sun? What? Okay, not really, not really. Do not digress from the discussion. Okay, let's stay focused on the discussion right now. Let's stay on course. Okay, not really, not really. Because Earth's surface is also receiving heat. No, Earth's surface is receiving heat. It is getting hot. It is getting hot. So Because of conduction, again the heat will pass inside also, no? That is why the core is still not core has reached an equilibrium. That is why the core is not cooling off. Otherwise, the core would have eventually cooled down. No. Imagine the core is hot, the surface is cold. So the core should have eventually cooled down. Right? Don't you think so? It would have just radiated the heat, its heat to outer surfaces. Eventually, the core would have cooled down and we would have had a solid crust. But the core is still in molten state after millions and millions of years. So why do you think that is? Because there is an equilibrium that has been established. The sun, the rays that you are getting from the sun, this heat is also getting conducted back to the core, and core is also radiating heat. So core is in thermal equilibrium. Okay, first law came before zeroth law. That's why. No, all I'm saying is why is this? All I'm saying is I'm trying to make you understand the significance of this law. Is this does this statement sound obvious? Does this statement sound obvious? That if A is in equilibrium with B and B was in equilibrium with C, then A and C should also be in equilibrium. Is it not obvious? So there is something hidden here. There is something hidden here which you don't realize. Okay, there is something hidden here that you don't realize. What is hidden is imagine the significance of this law. The significance of this law is that it tells you that there is only a single property responsible for thermodynamic equilibrium. So significance is this law tells us that there is a single property. There is a single property responsible for establishing the thermal equilibrium. Now, why is that? Why is that? Let's take up a hypothetical example. If we keep side by side A and C are either sides B of, then how? Okay. What? We keep side by side A and C are either sides of B, then how? Okay. Okay, so there is something else. There is something else, and I will explain that to you. Imagine hypothetically. Let's assume hypothetically. Now we know that only a single property is responsible for establishing thermal equilibrium. That is the temperature. That is the temperature. That is the significance of this law. With the help of this law, you can define that single property which you call temperature. So this is the basis of you defining the temperature now. Let's assume hypothetically thermal equilibrium could be established by two parameters. Okay, established if P was same, and if rho was same. So I'm taking a hypothetical example in which two bodies could have come in thermal equilibrium if they had the same temperature or if they had the same density. Okay, now consider an interesting situation. Now consider A, B, and C. And let's consider A and B and C. They have A, let's say, has a temperature of T and a density of rho. Okay, let's imagine that B has a temperature of T but a density of 2 rho, and C has a temperature of 2T and a density of 2 rho. Okay, let's imagine a scenario like this. Now you realize between A and B, because the temperature is same, so that would cause a thermal equilibrium between these two. The same T would have caused a thermal equilibrium between these two. Similarly, if then same density could have also caused thermal equilibrium. Then between B and C, there will be a thermal equilibrium because their densities were same. Now you realize, however, A and C both have different temperatures and different densities. So they could not be in thermal equilibrium with each other. Now do you understand the idea? Now do you understand the idea? I am considering a hypothetical situation. Right? In an imaginary universe, imagine two bodies would be in thermal equilibrium if they attain the same temperature or if they have the same density. In that case, I could show you a situation. This situation, A and B are in thermal equilibrium with each other, B and C are in thermal equilibrium with each other, but A and C will not be in thermal equilibrium. So it is not necessary. It is not necessary that if A and B are in thermal equilibrium and B and C are in thermal equilibrium, then A and C will also be in thermal equilibrium. So the only way that is going to be possible is if there was only one rule for establishing thermal equilibrium. That is, only one property has to be the same for establishing thermal equilibrium. Okay, do you get it? Do you get that? And that property is temperature. So this law rules out the possibility of any other property responsible for thermal equilibrium. Okay, does that make sense? It tells you that thermal equilibrium is established if only one property is common. A single property is responsible for establishing thermal equilibrium. That is what I am saying here. That the significance of this law is that this law tells us that there is a single property of the system that is responsible for establishing thermal equilibrium, and that property is what we call temperature. So this law becomes the basis for defining temperature. Without this, you cannot give temperature a definition. Okay, so that is the significance of this law. Anyhow, so now let's move forward and let's talk about temperature a bit. So moving forward, temperature now would be that property which causes thermal equilibrium between two bodies. And if I try to understand what temperature is, then temperature is a macroscopic physical quantity. So when I talk about macroscopic, so whenever we talk about physical quantities or physical qualities, we talk about macroscopic and microscopic. So macroscopic and microscopic. So microscopic properties are the properties which are at atomic or molecular levels. Macroscopic are the properties which are related to a bulk of a material. For instance, pressure by a gas. So pressure is not exerted by, when we talk about the pressure is a property that we associate with a bulk of gas, with some amount of gas. For a molecule, you do not talk about pressure. You will talk about its energy, its momentum. It can exert a force by having collisions. Okay, so pressure is something which is related to a bulk of a material. Similarly, temperature is a macroscopic property which is defined for a bulk of molecules. You cannot define temperature of a single molecule. Okay, it is defined for a collection of molecules. Okay, for a bulk of matter. So temperature is a macroscopic physical quantity related to our sense of hotness and coldness. In modern definition, we know that it is the measure of average kinetic energy of the molecules. Okay, that is what it measures. The absolute temperature, in fact, is giving you an idea about the average kinetic energy of the molecules or atoms constituting any material. And that is why absolute temperature can only have a lowest value of 0. There cannot be a temperature less than 0 because the average kinetic energy of molecules and atoms cannot be negative. Okay, the lowest value of average energy is 0. Kinetic energy can never be negative. That is why your absolute temperatures cannot be negative. Okay. Now, so as I said, when temperature was initially defined, then they wanted to measure the degree of hotness and degree of coldness. When we touch something, if something appears hot, then we say it is at high temperature. If something appears cold, then we say it is at lower temperature. So physically, I want to relate temperature with our sense of hotness and coldness. Okay. Now, the nature of flow of heat is from higher temperature to lower temperature. That is what all experiments will show you, that heat will always flow from higher temperature to lower temperature. Now we know the explanation for that also, right? A higher temperature means higher energy, average energy of molecules. So all these molecules are vibrating more vigorously. A lower temperature means these are not vibrating as vigorously. So imagine if I kept them in contact, these high energy molecules would have hit these molecules, transferred that energy, okay, until both of them would have achieved an equilibrium where every time this hits this molecule, this transfers some energy here, this transfers some energy here, but if this is moving more vigorously, this ends up transferring more energy here. So ultimately, when a thermal equilibrium is established, then both the molecules would have had average kinetic energy. Okay, so that is why we know temperature is a relative property. No, now we have absolute definitions for temperature. That is what absolute temperature is. Absolute temperature is not relative. Okay, Shivam. In general, all the other scales were relative. Okay, but absolute temperature is absolute. That is why it has the word absolute connected to it. Okay, it is not relative to anything. Anyhow, so now you know that is why the naturally heat flows from higher temperatures to lower temperatures. Now we can also measure temperatures using different temperature scales, and every scale uses some thermodynamic specific thermodynamic states of some specific substances as reference points. So to establish a scale of measuring temperature, I have to have some reference points. So whenever you measure something, so for instance, suppose whenever you wanted to measure length, first you had to define a length of 1 meter. Let's say we defined a length. We said, okay, this length we are going to call 1 meter. That is called a reference. Now with this reference, I can measure all the lengths. Any length that is double this length will be called 2 meters. Triple this length would be called 3 meters. So for whenever you are devising a scale for any measurement, you need a reference point. Okay, so every temperature scale uses some reference points. We'll talk about that. So let's talk about the commonly used temperature scales. Commonly used temperature scales are Celsius, Fahrenheit, and Kelvin. Now, the idea behind this is that I said temperature is a measure of degree of hotness and coldness, right? So I needed some reference points to measure degree of hotness and coldness. Usually, what that is taken is the first reference temperature. So theta 1 reference is taken as freezing point of ice, freezing point of water, and the second reference temperature is usually taken as the boiling point of water. Now, there was a logic of this also. Why do you think we chose freezing and boiling points of water? Yes, nothing, please. This is a revision. Okay. Okay, so what about this slide? Yes, nothing, please. This is a revision. I'm quickly going over some key concepts. Okay. But I tend to discuss a few things in a slight more detail when I realize that there might be some things that students don't really understand well. So those things I tend to discuss in details. For instance, the hi Bharti Darshan, how are you? Okay. For instance, the significance of Zeroth Law of thermodynamics. In my experience, most students do not understand the significance of that law. You guys don't even pay enough attention to it. Okay. All right. So moving to this. What I said was, so when I'm measuring the degree of hotness and degree of coldness, I needed reference points. Now, we choose these reference points as freezing point of water and the boiling point of water. Why did we choose these two? Why did we choose water? Any idea? Any idea why we chose water? Because of course, water is the most abundant molecule in this earth, right? Water is something that everybody knows, everybody uses, everybody has, right? Zeroth law has zero importance, right? That is why I discussed it. Arey, so change of state will occur anywhere, no? For all, it could have been, I don't know, freezing point of benzene and boiling point of benzene. Why not consider benzene? Why water? So what is so special about water? It's just the abundance. Okay, I am fine, sir. What about you, sir? Your class useful, my university exam. Thank you, sir. Absolutely, most welcome, Bharti. Okay, I'm great. I'm great. Thank you for asking. Now, the only reason why we chose water for reference points is because of its abundance and its availability. Water is easily available to anywhere and everywhere. To somebody who is, anywhere on Earth. If that is why we needed an absolute scale later. I mean, suppose on Earth I can communicate everything about water, and anywhere on Earth everybody else will know something about water. Suppose I had to communicate about my scales, temperature scales with some alien. Maybe that alien does not have water on its planet. Maybe those aliens they drink methane instead of water. I don't know. Maybe they drink sulfuric acid. Okay, then and they don't have water at their planet. Now that reference will not work anymore. Hydrogen bonding and 107-degree bond angle and three isotopes. That's why water. No, it's just simple plain fact that we have water everywhere. Everybody on Earth knows what water is. Everybody on Earth has water. So what we did was, the idea is if you touch ice. Okay, so this is not a practical idea, the theoretical idea though. So on one side you touch ice. Okay, on one side you touch steam. Okay, boiling water. Freezing water and boiling water you touch. Okay. So do not. I'll drink H2SO4 with them. Okay, good luck with that. See, our human body does not work like that. Maybe theirs will. So, all right. Anyhow. So imagine the idea is when I touch freezing water and I touch boiling water, I will sense a degree of coldness here and a degree of hotness there. So there would be a difference in my sensations. The degree of sensation, the difference that I feel, that is what I call the scale. Okay. So arbitrarily, we assigned this a value 0. We called that the feeling of hotness and coldness that you get when you touch freezing water. That is assigned a 0 value. And this was assigned a 100-degree value for Celsius scale. That is how Celsius scale came into play. We assigned these two numbers to the reference points. Okay. For, yes, instant burn, of course. Now, the idea is touch a third thing, touch something else. So, suppose if the difference that you are feeling between the hotness of ice and the hotness of boiling water can be called 100. If you feel half of that difference with something, then the temperature of that would be called 50. Okay, so do you understand? I have divided the difference in the hotness and coldness that I feel between boiling water and freezing water as 100. Now, if I feel half of that difference with with some third object, then I can say that its temperature is 50. If I feel 1/4 of the difference, then I will say its temperature is 25 degree, and that is how the scale is obtained. Okay, any scale is essentially telling you what is the difference in the degree of hotness and coldness relative to the difference in degree of hotness and coldness between ice and water. Okay, so now you realize for different scales you may assign any reference value. So for Celsius scale this was assigned 0, lower reference point, and the higher reference point was assigned a value of 100, and there were 100 divisions on that scale. Right, on Fahrenheit scale the lower reference value was defined as 32 and the higher reference value was defined as 212, and the difference was 180. For Kelvin scale these are the two reference temperatures and the division of scales is 100 again. Now, suppose if I wanted to relate the temperatures, so I know the degree of hotness and coldness between these two differs by 100. So if something lies in the middle, so can I say if 50, if I have a temperature which is 50 and it is the midpoint of this scale, so it should also be the midpoint of the Fahrenheit scale, 32 and 212, right? So this should also be the midpoint here also. So it should be average of this. So that is what we use in converting temperatures from one unit to another. Sir, if someone on Earth has sensory disorder, his scale will be different than ours. Yes, absolutely. Absolutely. But these are the standard scales, so which will allow you to get the sense of degree of hotness and coldness. Now, on one temperature scale can be converted into another by using this identity. What this is doing is that if you have a reading X on a scale, Then what is the difference of degrees with freezing water? It is this x minus the lower freezing point. And what is the difference between ice and water? It is this. Now the ratio of this should be constant for all scales. So if this value is lying 1/4 on one scale, on every scale, it would be on 1/4 of that 100 divisions, right? So that is the idea of converting the one's temperature from one scale to another. Okay, remember this formula? I hope you got that. I hope you got that. So I'll show you an example also. I'll show you an example also. Let's say I'm saying that you have something which has a temperature of 30 degrees on Celsius scale. What I mean is that the difference in degree of hotness and coldness of that thing with respect to ice, it is hotter than ice by 30 degrees. And ice is hotter or steam is hotter than ice by 100. So the ratio is this. Okay, so our thing is hotter than ice by 30 and steam is hotter than ice by 100. So I can say roughly the ratio of the hotness is this. So this will also be equal to, if something has F, if the same temperature is F in degrees Fahrenheit, then the degrees hotter from ice is this, and again the ratio of this is this. So this should always be constant. Okay, I hope you understand that. That is how I am getting this formula. That any temperature in Celsius minus 0 would be equal to any temperature in Fahrenheit minus 32 over the number of divisions on the Fahrenheit scale. So Prasad says, sir, I'm almost completed my entire syllabus, but I'm not confident. What should I do? So what are you not confident about? Your theory or your practice? Okay. So with this now I can convert temperatures in from one scale to another. Right. So let's try some of those temperatures. At what temperature the degree Celsius and the Fahrenheit will give the same reading? Okay. At what temperature of degree Celsius will the Fahrenheit scale and the Celsius scale have the same reading? Practice. Okay. So first of all, I think you need to revise your concepts better. See, I'll tell you what my experience says with students. What my experience says with students. So Dilip is absolutely right. Yes, B is the right answer. Well done. Okay. In my experience, so when you say you study and you have studied your concepts, most of the students again they know theory. Okay, they do not understand. There is a gap between knowing and understanding, and that is what is clear in your practice. Now, when you solve questions, solving questions will be happening from here. If you have understanding, then your problem solving will not be a problem. Okay. So, for most of the students, in my experience, the issue is that they know their theory, but they do not understand it very well. So, make sure you bridge the gap between knowing and understanding, because the day you start understanding your concept, trust me, you will start to solve problems. So, try and see what are the gaps in your understanding. Now, that is what problem solving does. Problem solving, if you're not able to apply your knowledge, then that just means you do not understand what you studied. Okay. So try and see what are the topics or subtopics that you do not fully understand. Try and first read more about them, try and understand them, and then trust me, you will become good at problem solving and you'll feel confident about your subject. Okay, that is my advice. All right, so let's solve this. As I said, that x minus 0 over 100 is equal to, again, x minus 32 over 180. So obviously, so you can use this. So what you realize is 80x plus 10x minus 18x equals 10x minus 32 to 10. So you realize 8x equals minus 32 into 10, and this is x equals minus 40. So yes, minus 40 is the reading where the Celsius scale and the Fahrenheit scale would read the same value. Okay. All right, very well done. Now let's try another one. A faulty thermometer reads 5 degrees Celsius at a melting point of ice and 99 at a boiling point of water. to find the correct temperature in Fahrenheit when the faulty thermometer is reading 21 degrees Celsius. Okay, how do you do that? Absolutely, Dilip. Yes, yes, that is what we did. So, how about this one? Let's see. What will the Fahrenheit scale read when the faulty thermometer reads 21 degrees Celsius? Okay, so try this and let's see. Okay, AP says B. Okay, I am not sure about this one. I don't remember the answer, but I think AB might be right. Let's wait for others. Let's see what others have to say. Let's see some other answers. Okay, let's try and figure out what the others think of this. Okay, anybody else? Or is AP the only one who tried this? When people try this, you know how to convert things from one scale to another. This is easy only. Come on, people. Let's see. Hmm. Okay, no one else is trying. Really. All right, let's see how you would have done this. So faulty thermometer reads the boiling point as 5. So the first reference temperature is okay. So instead of you can imagine that this is an imaginary scale where instead of 0, the boiling point, the freezing point of water is 5. This is the theta 1 of reference. Okay, this is the theta 2 of reference. Okay, so now all you need to do is write that 21 minus 5 over what is the range of this 99 minus 5, that should be equal to f minus 32 over 180. Okay, got it. Now did you get it? Our temperature scale is faulty essentially. That's not actually Celsius scale. So imagine this is some other scale where the first reference temperature is 5 and the second reference temperature is 99. Okay, I hope you got that. So now if you solve this, you will have 16 over 94 equal to okay minus 32 over 180. So f would be 180 times 16 over 94 plus 32. So that is what your answers would have been. Let's use the calculator a little bit and get this quickly. Now, जल्दी जल्दी कर देते हैं. So 180 16 over 4. So this is coming out to be 30.6. 30.6 plus 32. So that would be 62.6. So there. C is the correct answer, EP. Okay. The answer that we are getting is 62.6 and not B. Yes, Dilip. Okay, I hope you followed the logic of this, Shivam. Did you follow the logic of this? So essentially, even on the faulty scale, the ratio of degree of hotness and coldness should not have altered, right? Because all the scales are still linear. All these scales are supposed to be linear. I hope you know what a linear scale is. Linear scale is जैसे इस लेंथ को अगर मैंने 1 मीटर बोला तो डबल लेंथ वुड बी 2 मीटर, ट्रिपल लेंथ वुड बी 3 मीटर. दैट्स अ लीनियर स्केल. Okay. So since the scales are linear, so the ratios would again be always be the same, even if it's a faulty scale. Okay, all right. Now we'll talk about effects of heat. So as you know, heat is energy. So since heat is a form of energy, when supplied to a body, it can have the following effects. So I'll revise my notes of today. I will be perfect by tomorrow. Promise. Yes, absolutely. Don't worry. Don't worry. So as I said, whenever you provide something heat, then you're providing it energy. Now it can have two kinds of effects. Either it can increase the average kinetic energy of the constituent molecules. So you realize for any structure of solid, liquid, or gases, you have these molecules, you have these bonds. So they have their own kinetic energies because they are vibrating about their mean positions, right? So they have a kinetic energy of their own. And now due to these bonds between them, you know the bonds behave like springs. You should have studied this model, right? We treat the structures of solids like this as spring block models. So these bonds, they also, because of these bonds, they possess a potential energy also. Okay, bonds behave like springs, and springs inherently will have a potential energy associated to them with the vibration. Okay, so a solid structure or any structure in general should have had these two possibilities. Molecules can have their own kinetic energy, and they can have a potential energy associated to the bonds between interatomic bonds or intermolecular bonds, whatever kind of bond they may be. So when you are increasing, when you're supplying heat, you're increasing energy. So that energy can go into two ways. Either it can increase the average kinetic energy of the constituent molecules, and if that happens, you will see the temperature rise. Okay. Or you will see state change. So in state change, you will have the interaction potential energy changing. Or it can increase the interaction potential energy between the two constant molecules, which will be seen as thermal expansion or state change. So in state change, you realize when you're supplying heat, the water at 100 degree, by adding heat, it is converting to steam at 100 degree. So the temperature is not changing, which means the average kinetic energy of water, boiling water, is exactly same as the average kinetic energy of steam molecules at 100 degrees Celsius. Only the potential energy has changed. The interaction between them has reduced. Okay. Now, because these forces are attractive, so potential energies are usually negative. By the way, I hope you know that for attractive forces, the potential energies are negative, just like the interaction energy of gravitational force. That is also negative, gravitational PE. Okay. So when you give something heat, then there are two consequences possible. Okay. Now we will study about that. So first we'll talk about calorimetry. So calorimetry tells you the effects of the heat in terms of the change in temperature or the change in state. Right. Calorimetry is the branch involving measurements of heat transfer and relating them to state variables of a body associated with this heat transfer. So what are the state variables? State variables are usually okay. So when we are talking about state variables, we talk about temperature. Okay. Now, calorimetry. Metry is related to measurement. Calorie is heat. So, calorimetry is the branch of physics which deals with measurements of heat and effects of measurements any measurement of any effects of heat. Okay. So, using calorimetry, we can try and relate the amount of heat supplied to the change in state it produces. Example: change in temperature, change in dimensions, etc. Okay. Now, before we start, we need to define certain terms for our study. So let's take a quick look of. So why is this not moving forward? Okay, so that is weird. Okay. Let's quickly talk about the terms related to calorimetry. So first we will define 1 calorie, which is going to be our unit of heat. So 1 calorie. So I'm just quickly going over these key terms. 1 calorie is defined as the amount of heat required to raise the temperature of water by 1 degree Celsius at XTP, of course. Okay. Specifically from 14.5 to 15.5. You should know this definition. In mains, they have asked direct questions on these. No, the PPT is not over. You can see from here on this side, you will notice. I hope you can notice this. This is telling you the number of pages left. Okay. This is page 23 or 52. So the PPT I have is huge. Okay. It's not over by any measure. Okay. As I said, be very careful with your definitions. In mains, they have asked exact question on the definition of calorie. So 1 calorie is defined as the amount of heat required to raise the temperature of water by 1 degree at 1 atmospheric pressure, and that too from 14.5 to 15.5. Please note that this is very important. They had asked you this, and this has been asked in JEE Mains more than once, by the way. Exact question or over this definition. So make sure you know that. Next, we talk about heat capacity. Heat capacity, of course, is defined as the amount of heat required to raise the temperature of any body by 1 degree. So the heat capacity of this pen would be the amount of heat. If I supplied this, then the temperature of the pen should rise by 1 degree. Okay, so the heat and the heat capacity can be related by this. So for per degree increase in temperature, you need H amount of heat. If you wanted to increase the temperature by, like, let's say X degrees, then the amount of heat required would be H times X. Okay, it would be very simple. Then we talk about specific heat capacity. Specific heat capacity is defined as the amount of heat required to raise the temperature of a unit mass of a substance. So per kg of a substance, if you want to increase the temperature by 1 degree, then the amount of heat required is called the specific heat capacity, and specific heat capacity is related to heat by ms delta theta, where m is the mass, s is the specific heat capacity, and delta theta is the increase in temperature. Then, of course, you have molar heat capacity. The symbol for this is small s. Symbol for this is C. Molar heat capacity is defined as the amount of heat required to raise the temperature of 1 mole of a substance by 1 degree. So you should remember that. Again, the molar heat capacity can be related to the amount of heat with the help of this equation. So this is just a quick revision. So that's why I'm going over these definitions quickly one by one. Then you have latent heat of fusion. Latent heat of fusion was defined as the amount of heat required to completely convert a unit mass of a substance from solid state to the liquid state at a fixed temperature called melting point, right? And this is can be related with the heat as m times latent heat of fusion. Next, you have latent heat of vaporization. Again, that is the amount of heat required to completely convert a unit mass of a substance from its liquid state to its gaseous state at a fixed temperature called boiling point. And I can relate the heat with the latent heat of vaporization as Q equals M times LV. Okay. All right. Then there is another term which we commonly use in our calorimetry, which is called water equivalent. A lot of people do not know about this. It is defined as the mass of water that will have the same heat capacity as the given body. What do I mean? What I mean is that imagine if if I had this object, let's say pen, and the amount of heat required is some Q to raise its temperature by 1 degree. What I want to judge is the same amount of heat Q would have increased the temperature of how much mass of water by 1 degree. So if the same amount of heat Q can increase the mass of m kg of water by 1 degree, then I will say this the water equivalent of this is m. So for calculation purposes, I can replace this by m kgs of water. That is what water equivalent is. Once you know the water equivalent, then heat required can be related to water equivalent as mass in water equivalent times specific heat capacity of water. Now, another thing that you should know is what is specific heat capacity of water. The notes prep important for these terms of NCRT sufficient. Yes, yes, absolutely. Okay. Next, you should know specific heat capacity of water. Specific heat capacity of water is 1 calorie per gram per degree Celsius. That is just by definition. By definition, calorie was defined as the amount of heat required. 1 calorie was defined as the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. So specific heat capacity for water is 1 calorie per gram. Specific heat capacity for ice is zero point 0.5 calories per gram per degree Celsius. These two things you should memorize because at times means people expect you to remember these values. So Shiv says dynamic meaning. So dynamic is something that is changing. In general, dynamic is something which is changing. Static is something which is not changing. Okay. So let's say, when you say in physics, you talk about dynamic equilibrium and static equilibrium. So if you have a moving body, if you have a body, if the net force on this body is zero, then this can be said to be in equilibrium. If the net force is zero, summation F equals zero, then we say equilibrium hai body. Now इक्विलिब्रियम वाली बॉडी के दो टाइप हो सकते हैं ना, दो टाइप क्या हो सकते हैं? Either this body can be moving or it could be at rest. It could be either at rest or moving with a constant velocity. With constant v, right? If f is 0, then there are two possibilities. This just means acceleration is 0. F0 means acceleration is 0. If acceleration is 0, then the body will either be at rest or moving. Now, if the body is at rest, then the equilibrium is called static equilibrium. So, static equilibrium. And the body is moving, then it is called in dynamic equilibrium. So, why dynamic equilibrium? Because its position is constantly changing. Only two doubts are left to ask. Can I get appointment in some lectures? Okay, sure, sure. Let's see, let's see. The next class you can come. Class fail. Next class, I'll clear your doubts. Okay, don't worry about it. Now, do you understand the word of the meaning of dynamic? Dynamic is something which is changing. Now, you say that in thermodynamics also, two bodies are in dynamic equilibrium. Dynamic equilibrium means that they are exchanging heat, but the rate of exchange of heat is equal. So that is why the equilibrium is called dynamic. Dynamic means that does not imply that the heat is not being transferred. The heat is being transferred, but the net heat transfer is zero. That is why thermal equilibrium like this is called a dynamic equilibrium, because the amount of heat is still changing individually. The net heat is not changing, however. Okay, so anything dynamic means that. So dynamics is the study of things that are moving, and statics is the study of things that are at rest. Okay, so in fluid statics, you talk about study of fluids at rest. In fluid dynamics, you talk about fluids that are moving. Okay, so that's the general idea of dynamic and dynamics. Okay, I hope you got that. Shiv. All right, moving forward, these are few values that you should remember. You should remember the latent heat of fusion of ice. Latent heat of fusion of ice, that is 80 calories per gram, and latent heat of vaporization of water, that is 540 calories per gram. These are a few values which you can memorize, because sometimes the mains people expect you to remember these values. Okay, make sure you remember these values. Okay, easy to remember. Only four values. Only four values you will need to remember in your calorimetry. Okay, now let's take a look at some questions. Okay, now we'll talk about principle of calorimetry. So, principle of calorimetry states that for a thermally isolated system, the total heat lost by hot bodies is equal to the total heat gained by the cold bodies, which is very, very simple. This is nothing but principle of conservation of energy. So, mathematically, essentially, for all the bodies in an isolated system, the summation of all heat changes would be zero. Okay, so that is what this thing says. Now, why don't we try a question? So, I hope you got the logic of this. Is based on principle of conservation of energy. So anything. So imagine if I left three things A, B, and C in a container, and imagine they end up exchanging heats. So this is giving this heat, this is giving this heat, and this is giving this heat. So eventually, all the heat gained by B and all the heat lost by A and C would be equal. Okay, because the net exchange of heat is happening within themselves only. Okay, so that is as simple as that. So let's try a question with this. Okay, okay. So I don't know if the options are visible. Now they should be. So three liquids A, B, and C have the same masses and are initially at temperatures of 10 degrees Celsius, 20 degrees Celsius, and 30 degrees Celsius respectively. When liquids A and B are mixed together, the final temperature of the mixture is found to be 18. When B and C are mixed together, the final temperature is found to be 24. What will be the final temperature when you mix liquids A and C? So try and solve this. Okay. So A is at a temperature of 10 degrees Celsius, B is at a temperature of 20 degrees Celsius, and C is at a temperature of 30 degrees Celsius. When you are mixing A and B, you realize that the temperature of the mixture becomes 18. When you mix B and C, you realize the temperature of the mixture becomes 24. What will be the temperature of the mixture of A and C? Okay, so try this. Okay, Shiv says, and iska matlab, kya we have to study the dynamics of this block? So when you're saying the dynamics of this block, then that means the motion and causes of motion of the block. Okay. So dynamics is usually refers to the causes of motion also. Everything about motion. So when you're talking about dynamics of this block, then that means you have to study about motion. You should know how to analyze the motion and how to study the motion. Okay, how it moves, why it moves. Okay, so that is what you're trying to study. Okay. Dynamics mostly refers to why of things. So what, so basically how it responds to forces and something like that. All right. So anybody with the answer of this one? Anybody having an answer of this one? So try this question quickly. Come on, people. We do not have too much time. Okay. All right. So let's hurry up with this one. Any answers for this? So how would you say? Three liquids have same masses. Please pay attention to the language and please pay attention to the key information. Three liquids have same masses and their temperatures are given to you. So how you would have solved? Let's see. Let's see. So imagine when you are mixing A and B. A and B. Now A will receive some heat due to B. And can I say heat lost by B will be equal to heat gained by A? Okay. What is the heat lost by a B? Heat lost by B would be M. Let's assume that this has mass M, this also has mass M. M times specific heat capacity of B, and the temperature of B dropped to 18 from 20. Okay, so the amount of heat lost by B is this. This should be equal to the amount of heat gained by A, which would have been this. Because the temperature of A became 18 from starting from 10. Agreed? So this will help me that I can say that S of B, the specific heat capacity of B is nothing but 4 times the specific heat capacity of A. That is the first equation that I'm getting. Similarly, when B and C are mixed together, C will give some heat to B. C will be losing temperature, B will be gaining temperature. Right. So and the amount of heat lost by C would be equal to the amount of heat gained by B. So also I can say that if the amount of heat lost by C is m times mass of C, and what is the temperature drop that C experiences? Its temperature reaches 24 from 30. So it cooled by 6 degrees. This should be equal to m times, again the mass would be the same m times S of B times the change in temperature of B. B goes from to 24 from 20. So 4. So from here what I realize is that 2S of B is equal to 3S of C. Agreed. So from here, what I will realize is I can find the relation between S of A and S of C. So from here, I will say 3S of C is equal to 8S of A. Correct. That is the relation between the specific heat capacity of C and specific heat capacity of A. Now, when A and C are mixed, C will lose some heat to A, and let's assume that the final temperature is some theta. So the amount of heat lost by C would be M S of C times 30 minus theta, because its temperature will drop from 30 to theta, and the heat gained by A would be m times h of A times theta minus 10 because its temperature rises from 10 to theta. Now all I need to do is solve this equation. Now I can also use this relation. So I can say SC into 30 minus theta can be written as SA. SA is 3SC by 8 and into theta minus 10. All I need to do is solve this, and this gets cancelled. So 8 into 30, that is 240 minus 8 theta is equal to 3 theta minus 30. So I'm getting 11 theta. 11 theta equals 270. Okay, that is what I'm getting. Yep, with these values, that is what I'm getting. So theta should be equal to 270 over 11. So that will be higher than 20, and what would that be? 25 point something. 25 point something should be the answer. So it should be around this. The nearest option is this. Okay. Okay. I hope you guys paid attention to this. This is how you would have solved this. Okay. Next, let's try one more problem. It says a steam of 100 degrees Celsius is passed into 1.1 gram kg of water contained in a calorimeter of equivalent to this at 15 degrees. Still, the temperature of the calorimeter and its contents rises up to 80 centigrade. Okay, what is the mass of the steam condensed? Again, you need to realize that whatever steam is getting passed will get condensed to water, and then that water will also cool down. Will also cool down from 100 to 80. Okay, final temperature has to be 80. So, how you would have solved this? Okay, let's just quickly tell you how to solve this because we are running out of time. What you have is you have, let's say, m mass of steam. M steam first condenses. First condenses to m water at 100, right? And then cools to this water cools to m water at 80 because that's the final equilibrium temperature. So this is where the steam is losing heat. Okay, so AP says 0.26. Okay, let's see if that is correct. I don't really remember the answer. Okay, so this is the part where the heat loss is happening, and where is it being gained? I can say there was 1.1 plus this, so 1.12 kg water at 15 degrees will convert into 1.12 kg water at 50 degrees. So this is the gain of heat happening. So all I need to do is use the principle of calorimetry, put the amount of heat loss equal to the amount of heat gain. So I can say M into latent heat of fusion, which is 540. Okay, that is C not given. This is what happens in most questions. They do not give you that because they assume that you know it. Again, so this is for grams. Okay, so please remember, we'll be taking all of these things in grams. For kgs, it will become into 1000. This is the heat that is lost here. Heat lost here is this. Heat lost here would be written in the second term. So I can say plus m into 1000. That would be the specific capacity for water. Into the loss in temperature is 20. That is the term this, and this should be equal to. If we go to the total heat gained by this, which will be 1.12 into 1000 into the temperature gained by this, that will be 65. This is this term. The term representing the heat gained during this. Okay. Now all you need to do is solve this equation and you can find the value of m. First, let's get rid of these thousands. What I have is that E equals 1.1265 over 560. So that would be our answer. Let's see how much that is. I think AP might be correct, huh? Seems right. 0.1225. So it is coming out to be 0.13 AP. 0.13. Yes, we do have that is an option. Okay, not 0.26, but in fact 0.13. Okay, so see, you did some calculation mistake somewhere. Okay, don't worry about it. That happens. Okay, so that is it. That is it. That is it. This is a problem which I would give for homework. So you can try it and practice this problem on your own. You've been told that 2 kg of ice is at minus 20 degrees Celsius is mixed with 5 kg of water at 20 degrees Celsius in an insulating vessel having a negligible heat capacity. To calculate the final mass of the water remaining in the container. Okay, it is given that the specific heat capacities are this. Okay, so do this. This is your homework problem which you can do for practice. Next is thermal expansion, and we will start our discussion on thermal expansion in the next class, which will happen next Friday. Okay, so that is it. That is where I would like to wrap up today's session because we are almost out of time for today's session. Okay, all right. Now, before I leave you guys, let me remind you one last time. If you haven't gotten your Unacademy subscriptions yet, you should be getting them right away. And this is how you do it. So all you need to do is go to the plus section of the app, select your goal as IIT JEE, and click on the get subscription button. Okay, that is all it takes to get this subscription and unlock the wonderful features of Unacademy Plus. Now, when you redirect it to the payment page, do not forget to use this code RDLive to get a cool 10% off on all your subscription fees. Now, you can choose from the Plus or the Iconic subscription, and when you click on Proceed to Pay, you can also choose from a lot of no-cost EMI options for to choose from to make your payment. Divide this into any number of EMIs, which will help you, ease the burden of the payment. As I keep saying, keep reminding you, you can also choose from the Iconic subscriptions now. And the Iconic subscription will take your JEE preparation to the next level. Okay, you'll be assigned personal coaches. Then you will receive IIT JEE workshop, which got guidelines, study planners, and test analysis sessions. These will take your preparation to the next level. Now, as I keep telling you, that Unacademy is also providing you the opportunity to study from the topmost educators all across India from the comfort and safety of your home. So now, top educators from Bansal classes have also joined Unacademy. You can now enroll in their batches. Their batches for 2023 are going to start very, very soon. All right. So with that, let's come to this. If you like today's session, if it helped you revise your concept and get some practice, then do not forget to press that like button. Also, share it with as many people as you can. So as we guys know that not all students can afford this subscription. That is why we have brought this channel for you, okay, where all the content for 11th and 12th is being provided completely for free. Okay, so that is where you can use and is where you can study quality content absolutely free of cost from this channel. So share it with as many people as you can. Make sure more and more people are benefiting out of this. Now, those of you who are new to this channel, don't forget to subscribe and don't forget to press the bell icon, okay, to keep receiving timely notifications. Now, PDF of all the slides used in today's lectures would be available for download very, very soon. And those of you who are following us on the YouTube channel of JEE English channel of YouTube should be connecting with us on the Telegram app using this link. This link will make sure that you're receiving all time notifications and you are not missing out on any of the lectures or amazing sessions happening on this channel. Okay. So with that, I would like to take a leave. We will meet again next Friday where we will continue the discussion of thermodynamics. We'll talk about thermal expansion. Till then, you guys take care of yourselves and let me remind you one last time. This is the code. So if you are planning to get yourselves the Unacademy subscription, use this code RDLive, get another 10% off and enjoy the Unacademy subscription. So all right, so I'll see you next Friday. Till then, you guys keep studying hard, keep practicing, and take care of yourselves. Bye-bye.